Hey everyone, this is Dr. Walker. This is video 572, the Biot Savart Law. This video we're going to examine this law, which was arrived at through experiments by two physicists named Biot and Savart. The law gives the magnetic field of an isolated current element at some point. Let's examine what it says. It says dB, and this is the magnetic field created by that current element, is equal to mu naught. Mu naught is a constant. It's called the permeability of free space. It's given by 4 pi times 10 to the negative 7 Teslas times meters over amps. So mu naught divided by 4 pi, then I ds cross r hat over r squared. So I is the current in our wire or in our conductor. ds is a length element. So you can split up that wire into a bunch of little elements that have a length ds. And the direction of ds is in the direction of the current. Cross r hat. So r hat is a unit vector which points from the length element ds towards the point P where we're calculating that magnetic field. And we're dividing by r squared, where r is a distance from the length element to that point. This equation should look a little bit familiar. If you remember, we found the electric field back in the day. We found Ke dq over r squared, and this was also in the r hat direction. So the electric field, due to an infinitesimally small charge element, depended on the distance squared from that element to the point, and it had a direction r hat. In this case, the magnetic field, due to a current element, depends on the cross product, but it also has the inverse r squared dependence. In order to get the total magnetic field due to the entire current distribution, we just have to integrate, right? The b here is going to equal to the integral of dB. So we just integrate the expression that we have for dB to get the magnetic field for the total current. We integrate over the entire current distribution. Let's take a look at a your turn. It says, at which point is the magnitude of the magnetic field due to the current in the length element ds the greatest? So at which point do we have a higher magnetic field? And we can write down the Biot Savart law just for our reference while you think about it. Mu naught over 4 pi I ds cross r hat over r squared. Okay, so you had plenty of time to think about it. We know that the magnetic field depends on the distance. So we know that the closer that we are, right, the smaller the distance, the larger the field. So just from that, you might think, well, point B is the closest, and then point A, and then point C, and then point A is the farthest away. And that actually does give you the correct answer, that the field is greatest at point B. However, you still want to take into account the fact that there is a cross product ds cross r, so it's good to practice writing down, drawing the r hat vector, which points from that ds element. And let's imagine that ds element started here, right below b, so the r hat points from the ds element to that point. So in this case, at point B, the angle between ds and r is 90. So the cross product is just going to be equal to ds, right? Whenever ds and r are perpendicular to each other, then ds cross r is going to equal to ds, which is the length of the vector ds, times the length of r hat, which is 1 since it's a unit vector, and sine of 90, which is equal to 1. So the cross product is just equal to ds when they are perpendicular. However, for point C, if we draw it in a different color here, we have the unit vector is going to point towards point C. And so there is going to be an angle theta between ds and r, which means that the cross product will be ds cosine sine theta, which will be smaller than ds. And then for point A, the r hat vector is pointing towards A. So ds and r hat are parallel, and we know that the cross product is equal to 0. So the field is equal to 0 at point A. So this was just some practice starting to use the Biot Savart Law, but we're going to do an example in the next video.